This is your hacker Nikolai Cyan. Welcome to the stream. Welcome, Erixa, Erisectrum. Welcome, V+, hello. Welcome, Enoki. Welcome, MySpeed200. Welcome, Paul, hello. Ohayo gozaimasu. I'm guessing it's not Cyan himself who started a live stream now. Who started a live stream? Is it my cat? Is it my cat that started a live stream? Okay, slide mode. Damn it. Okay. No. Ayu is a good color scheme. Hello, Anden. Welcome to the stream. Today we're learning generics, trait, and lifetimes. How exciting! It's like the most important thing in Rust, isn't it? Isn't it? It's what makes Rust so powerful. To be very honest, I was not very good with generics in other languages. So I'm super excited to learn this from the beginning. I think the Rust documentation does a really good job for people like me with needs improvement in the basics. So I'm super excited to start learning those. Havnia, welcome. Cyan sensei, teach me Rust. I'm not Cyan sensei. I can't teach you Rust. Go find the documentation. And you'll be good at it. Yes, everybody is super happy in the morning or night with a clear mind. Let's get started with generics. Generic types, traits, and lifetimes. Every programming language has tools for effectively handling the duplication of concepts. In Rust, one such tool is generics. Generics are abstract standings for concrete types or other properties. When we're writing code, we can express the behavior of generics or how they relate to other generics without knowing that what will be in their place when compiling and running the code. Similar to the way a function takes a parameter with unknown values to run the same code on multiple concrete values, function can take parameters of some generic type instead of concrete type. In fact, we already used generics in Chapter 6, Option T, Chapter 8, Leg T, and hash map, key value, and Chapter 9 with result. In this chapter, you'll explore how to define your own types, functions, and methods with generics. We have used generics before. Options, vector, hash map. They're all generics. I skipped the error handling chapter because I wanna learn about generic first, and if we have extra time, we can go back to error handling if my internet permits. So yes. Really welcome. I'm gonna cry. You did such a good job. It's so pretty. Guys, check out Ravioli. The drawing is so pretty. It's like the drawing is like dancing in all sorts of things that I like. It's dancing. It's dancing in my head. I'm gonna cry. Let me share the drawing. Ravioli drew a Cyan that is so adorable. I'm just gonna cry. Guys, check it out. It's so amazing. It's my desktop right now. It's so pretty. Do you know why I was late for stream? I've been staring at this picture over and over again. It's just too pretty. It's so cute! I want to stare at my background all day. Thank you so much for joining us very early. Let me actually show it. Give me a second. I think our Rust would appreciate a cute drawing. Everybody go follow very early. This is just purely amazing. This should be my thumbnail for my next stream. Well, not for next stream, for a very important stream. Okay, I know you guys are here for programming. Sorry for the interruption, but I just like it too much. Thank you so much, really. Alright, okay. Going back to generics. With an option, vector, and hash map. Or generics. And now it exists to reduce code duplication. Next, we'll use the same technique to make a generic function from two functions that differ only in types of their parameters. We'll also explain how to use generic types in struct and enum definitions. Then you'll learn how to use traits to define behavior in a genetic way. We're going to learn traits. We can combine traits with generic types to constrain a generic type to only those types that will have a particular behavior. As opposed to just any type. So if we want to constrain a behavior on a certain type, we use traits. Welcome, Fifi. Welcome, sensei. Finally, we'll discuss lifetimes, a variety of generics that give the compiler information about how references relate to each other. Lifetimes allow us to borrow values in many situations while still enabling the compiler to check that references are valid. Lifetimes! I heard it's hard. So let's go directly into it. Does it have a chapter introduction? It doesn't. It just goes right into the example. Ooh! So this is a chapter introduction with code. Let's see. We can remove duplication by extracting a function. So initially, we have this code, which initialize a vector, and we define a mute integer variable. That's the first of a vector. That's the first number in the vector. And then we're trying to find the largest number. And then we're testing if it's equal to the number that we want. But to make the code more reusable, we can extract the function of finding the largest. Function largest, a list of integers, returns a integer I can just copy this in. And it returns largest without a return statement. Hello, Doohoo, welcome! Now we can call it. we pass in a reference to the number list. Give it a name. And we will have our largest number. Like that. So if I run this, oh, we need to use list. List? What's the name of it? Number. Okay. Hello team, welcome. The Rust syntax are really weird. I guess you get used to it. It's quite different, I would say. So if we have two lists, then we can reuse the function. I panic. Oh. Because I didn't update the check. Okay, it works. It works. But how does it have to do with generics? Because to make the function more general, we can also do a character comparison in addition to the integer comparisons. So if we have a bunch of characters like those, we can find out the largest character. One way to do it is to duplicate the code and write the whole thing again, which is apparently very duplicated. It's not good, that's too many code. So we can use generics. How do we use generics? How do we use generics? Okay, let me first write the character list. Era list. Ah, the chat is off stream. Ah, I forgot to put it back after the singing stream. Thank you for reminding. Oi. Oi. Oh, it's tiny now. Maybe okay. Okay. So we have our character list. Let's put characters in it. How about Cyan? C Y A N C Y A N. Okay? Oh, not okay. I put a character in the number list. I sneezed and I mute myself. Okay, so how do we generalize the type to be both integer and characters of string slice? We can do the generics. Let's see how we explain it. To parameterize the types a new function will define, we need to name the type parameter, which is t by convention. It's a short for type. When we use a parameter in the body of the function, we have to declare the parameter name in the signature, so the compiler knows what the name means. Similarly, when we use a type parameter name in the function signature, we have to declare the type parameter name before to use it. So to define the generic largest function, place a type name declaration inside the angle bracket between the name of the function and the parameter of the list. To do that, we put the type in here, and now our list is a vector of generic type. And then, because we're returning the largest of the type, we're returning the t. I click on the wrong button. Good night， 谢谢皮妈，皮妈好好休息，好好休息。Okay, but here comes a problem. After we define the type, the problem is not every type can be compared. Not every type can be compared. So there is a restriction of the type that can be compared. We only want the type that can be compared. And how do we do that? Does it explain? Does it explain? It just ignores it? What? Does it ever come back to it? Oh, here we go. It's the next chapter. Welcome, Makikoko. Hello. Okay, so because we need to compare the elements in the vector, we need to make sure our type is comparable. So we give it a partial order. And you still implement the copy trade. And implement the partial order. The partial order plus copy. After doing that, we can do a comparison. Result list. To do a largest in list. Result 1, result 2. So now, because we have the generics, we can do comparison. We can find the largest in number list and list. The largest character It's result 2. What's the largest character in Cyan? It is Y. It is Y. Okay, let's see if it works or not. Let's see if it works. Cargo run. Yay! It works! That's our first generic program. The largest number is 120, and the largest character in Cyan. Oh, it's Y. Awesome. Okay, going back to tutorial. I'm jumping around way too much. Okay, we passed this, and now let's continue somewhere. Let's continue somewhere. Here. Other ways of using generic type parameters. We can define structs with generics. So we have a struct of a point. We define a point that doesn't only take integer. So x is t, y value is also t. Welcome, dang. And then we have a main function that gets some instances of the point. Integer point, which is push, which is gives it some integer. Values, and let float. We can give it float values because it doesn't care what kind of type we put into it. Can we print it? I think we need to do the derive thing. I'll let the compiler give me that command because I'm lazy. Oh, I need to actually put a string in it. Like this. Anyways, give me something. It doesn't give me the derived thing. Huh. Hello! Julia, welcome! Be careful. How do I print them? Float. Float. Okay, finally. I can add this to the top of the struct so it can be printed. Just like debug. Should be all good. Yay! Got printed! Welcome, Mohammed. Hello. Thank you, Alex. So, yay, we can use generics to create a struct. Nice. Oh, now it's showing an example that because we use this, the X and Y has to be the same type. So if we have an integer and a float, it confuses. Because it says X and Y are the same type. So we can define another type, another generic type. It's supposed to be a comma. And it should work. Yeah, it works. So this is how you do different types in generics. Use more than a few makes your code hard to read. So when you need a lot of generic types in your code, it could indicate that your code needs restructuring into smaller pieces. Okay, that's generic for structs. Oh, we can do that. We can put the variable in and have it formatted. Let's try it. Boom, works. Nice. Nice, Rust. Awesome. Okay, moving on to enum definitions. We can define enums to hold generic data types in their variants. So, the option we have using actually uses generics. It's generic over type T and has two variants, sum, which holds the one value of type T, and none, which doesn't hold any value. By using the option T enum, we can express the abstract concept of having an optional value, and because option T is generic, we can use this abstraction no matter what type of the optional value is. Enum can use multiple generic type as well. The definition of result enum that we use in chapter 9 is one example. Also, it's using multiple generic type of type and arrow. The result enum is generic over type and arrow, and it has two variants, OK, which holds value of type T, and arrow, which holds value of type E. This definition makes it convenient to use the result enum anywhere we have an operation that might succeed. Or fail. So when succeed, it goes to OK. When arrow, it goes to arrow. In fact, this is what we use to open a file in listing 93. Okay? Where T was filled within type file when file was opened successfully, and E was filled with the type arrow when there were problem opening the file. Ooh. When you recognize the situation in your code with multiple structs or enum definition that differ only in the types of the value they held, you can avoid duplication by using generics typing instead. Okay, moving on. Thank you, John. Thank you for visiting. In method definitions, we can implement method on structs and enums, and use generic types on their definitions. What's this code doing? So it got a point of the same type. Hello, Jax. and we give it a method. Point t. We give a method of t. Which returns itself. Self.x. Which returns the x. Which returns the x. And now the main function. Let me call it point. So we have a point. I want to return its x. So point.x. Can I just do this? It doesn't seem to recognize it. I don't think I can do this. And throw it in. Point. Any compacts need to go outside. Yes, sir. Yes, sir. Okay. Oh, this one needs to be a 10. So here we implement a method that uses the generic type t and returns the x, which can be anything. So here it can return me 5. So if we have another point, abandoning a character point of like 5 and 10, it should return me a string of 5. Oh yeah. Did I learn Golan? I used it for like a project at work, but then I forgot about it. I just remember the really weird way of like there's something that's written backwards. Is it like the type? You first write the type and then you write the variable name? What kind of projects do I work on? Is it for stack stuff at work and at school? And just something I'm interested in. I want to work on more projects because I'm currently not working on much. Yes, I'm learning Rust. Good morning, Adam. Welcome. Hello. Okay, what is this? Here is another. Oh, this is calculating the distance from origin. The code means the type point float 32 will have a method named distance from origin. Can I use it? I think so. Oh, it could be a big chunk. Let's try using it. Actually, I want to see how they do it. Okay. They define it in different implementation block. And here is a point. And we can calculate the distance from origin, I think. Can we? It needs to be float 64. Okay. This should calculate the distance. Hopefully. It does! Nice. So you can define a method for a specific type. But if I make it into an integer, will it still do this thing? I don't think so. Because it wouldn't. It says there's no such method. They define it in a different block because the point has to be float 64 for the function to work. Yes. So if this is a different type, you have to define it in a different block, right? F32 will still work. Okay, let's try. I was a little worried it won't. Looks like there's no problem. It still worked. Awesome. Awesome. Nice. Moving on. What do we have here? What do we have here? We have a point of different types. It's a mix-up type. Self-order. So you can use one point and mix up with another and produce another messed up point. So the first point is 5 is this, and the second point is that. And if we do a mix up, look at the type. It takes this type, I32 and char. It mix it up. Tawa. They mix it up. So you will get a 5 and C. Oh, that's how you play with generics. We can have mixed up types. That is so cool. The purpose of this example is to demonstrate a situation in which some generic parameters are declared with implement and some are declared with the method definition. However, the generic parameters x1 and y1 are declared after implementation because they go with the struct definition. What is this? The generic parameters x2 and y2 are declared after function mix-up because they're only relevant to the method. Oh, so this is the generic that is declared in the method definition. Ho. Performance of code using generics. You might be wondering whether there's a runtime cost when you are using generic type parameter. The good news is that the Rust implements generics in such a way that your code doesn't run any slower using generic types than would with concrete types. Rust accomplishes this by performing a monomorphization of code that is using generics at compile time. What is monomorphization? Monomorphization is the process of turning generic code into specific code by filling in the concrete types that are used when compiled. Okay, so you fill in the concrete type when compiled. In this process, the compiler does the opposite of the step we used to create generic function. Okay? The compiler looks at all the places where generic code is called and generates code for concrete types the generic code is called in. Oh, so it generates code for the specific type that is called in. So when we use like option T, when Rust compiles this code, it performs monomorphization, and it reads the value that's being used in option T, which is one is I32 and the other is float 64. It expands the generic definition of option T into option I32 and option F64, thereby replacing the generic definition within the specific ones. So it just puts the specific ones in it. 半形好高级，好高级的声音，好高级的说法。Lifetime is simple. Just follow one principle. You don't do stuff that's bad. Ooh. I'm excited. Is next chapter lifetime? Monomorphization. Monomorphization. Okay. Generics 也叫泛型。I actually don't know how to code in other languages. If I were to learn coding in like Chinese or any other language, I need to learn from the beginning because I don't remember all the names. Okay, the monomorphized version of the code looks like the following. The option T is replaced with specific definitions created by a compiler. Ooh. Because Rust compiles generic code into code that specifies the type in each instance, we pay no runtime cost for using generics. When the code runs, it performs just as it would if we had duplicated each definition by hand. This process of monomorphization makes Rust generics extremely efficient at runtime. Okay. Oh, we're finally getting to trades. Define shared behavior. A trait tells Rust compiler about functionality a particular type has and can share with other types. We can use traits to define shared behavior in an abstract way. We can use trait bonds to specific. We can use traits bonds to. We can use trait bonds. We can use trait bonds. We can use trait bonds to specify that a generic type can be any type that has certain behavior. Traits are similar to a feature often called interfaces in other language, although it has some differences. Okay, so this is similar to interfaces. Defining a trait. A type's behavior consists of methods we can call on that type. Different types share the same behavior if we call the same methods on all those types. Trait definitions are a way to group method signatures together to define a set of behaviors necessary to accomplish some purpose. For example, let's say we have multiple structs that hold various kinds of amounts of text. A news article that holds a news story filled with a particular location. And a tweet that can have at most 280 characters long, along with metadata that indicates whether it was a new tweet, a retweet, or a reply to another tweet. We want to make a media aggregator library crate named Aggregator that can display summaries of data that might be stored in news article or tweet instance. To do this, we need a summary from each type, and we'll request the summary by calling the summarize method on any instance. Shows the definition of public summary trait that expresses this behavior. So we have a summary. I just copied everything. It only has the summary. So we can define a public summary trait. That returns a string. Here we declare a trait using the trait keyword and then the trait's name, which is summary. We also declare the tree as public. So the crates, depending on this crate, can make use of this trait too. Inside the curly braces, we declare the method signature that describe the behaviors of the types that implement this trait. After the definition, we use a semicolon. Each type implementing the trait must provide its own behavior for the body of this method. Ooh. So we just define it here. Each type implementing it is its own definition. The compiler will enforce any type that has summary trait will have the method summarize defined with this signature exactly. Medium Blue, welcome! My summary sounds like submarine. Submarine? Ahoy! A trait can have multiple methods in its body. The method signatures are listed one per line, and each line ended with semicolon. Hello, highly intelligent Owen. Implementing a trait on a type. Now we have defined the desired signature of the trait's method. Of summary trait's method, we have defined this. We can implement it on the types in our media aggregator. So let's see the code. Hello, Resmax! Welcome! Welcome! You've been watching so long. How are you doing? You're from Japan? Konnichiwa! Konbanwa! Yoroshiku! And my cat is here to join me. Hello! Pet. Okay, so we have a public struct article It has public headline, location, authoring, content. And we implement a summary. We implement summary for news article here. We implement this trait. It has the exact same function signature. And it says headline by author in this location. And we have a struct tweet that has username, content, reply, and retweet. And here we implement summarize as that. So we put the trait name we want to implement after implement. And use the for keyword. And specify the type we want to implement the trait for. So this is how we do it. Implement the name of the trait or the type. Within this block, we put the method signatures that the trait definition has defined. Instead of adding a semicolon after each signature, we use curly brackets and fill the method body with specific behavior that we want the methods of the trait to have for the particular type. So, how we define for news article is different from tweet, because on tweet we use username and content. Someone writes summary. Mary. Welcome, Yuko. What programming language do I usually use for backend? I don't have a specific language. As I work on different stuff, it's like different language. Recently, I mostly used Java for work. I used Go. I used Python. This depends on the needs of the project. Hello, Lumid, welcome! Have I worked on Java project? Yes, I've worked on some Java project. Lucilla, welcome! Hello, Yeti, welcome! Okay, so where are we now? Aggregator. Not that the library has implemented summary trait on news article and tweet. Users of this crate can call the trait methods on the instance of news article and tweet. In the same way we call regular methods. The only difference is that the trait has to be brought into scope as well as the types to get the additional trait methods. Do we put it into a different file? Or is it okay if we put it on the same file? And my cat is trying to smash my monitor. Hello, don't smash my monitor. You're gonna get hurt. You're gonna get hurt. Bye-bye. Have I used Vim? Yes. Yes, sir. It makes me feel like I can create another file. not really a test. How do I name it? How do I name it? Dang, it's so hard. It's so hard. I just call it summary. And what I do with it, I just take the summary and twit from the main, from the other file. So if I do go wrong, oh, I don't think it's saved. Okay. Ah. What? I thought they can be on different file. Can they? Okay, what's up? Main function is right here. Oh, it disappears. Good. Analyzer is doing some good work, so unresolved import. So do I go into to here and import the aggregator? I got angry from the compiler. No! I think it's Rust Analyzer. Aggregator Rust. How do I import you? G streamer base, what? Do I not need to give it a... Do I not need to give it a version? What does aggregator do? Okay, I do not know how do I get the aggregator. I don't think he ever mentioned it. Did he ever mention it? Mold crate. Into mold rs lab rs. Something has to do with the mold? Do we have a mold folder? What's going on? Let's run it and see what it says. Okay, it says what exactly the analyzer said. Mold summary. Where do I write the mold summary? I'm so lost. YouTube filter chat. You need to match the file name. In their example, they have two cargo projects. One is a library called aggregator, and another is the main Rust file. Oh. We have 2 projects. So I could just move it. I didn't know how they were structured. Oh, okay. So moving them into one file works. But apparently I should have 2 projects. I can just add a mode summary. Will this work? Ah, worked. Okay. Okay. What is that? Oh, it worked. It worked. Yeah. I can import the summary module by using the mode summary. I'll save 才能够分析 OK. Nice, it works. Thank you guys. I was so stuck. Glad it worked out. Thank you guys for helping. I can do cargo new library for a new crate in a different place and put a past dependency on it. Oh, that's how you create libraries. Dang, I forgot. I forgot all the project structure stuff. Okay, finally moving on. I should read this. Other crates depend on the aggregator crate can also bring the summary trait into scope to implement the trait on their own types. One restriction to note with trait implementation is that we can implement a trait on a type only if at least one of the traits or the type is local to our crate. We can only implement a trait on a type only if at least one of the trait or the type is local to our crate. For example, we can implement standard library traits like display on a custom type like twit as a part of our aggregator crate functionality because the type twit is local to our aggregator crate. We can also implement summary on vector t in our aggregator crate because the trait summary is local to our aggregator crate. But we can implement external trait on external types. For example, we cannot implement display trait on vector t within our aggregator crate because display and vector t are defined in the standard library and unlocal to our aggregator crate. This restriction is part of a property program called coherence. And more specifically, the orphan rule. So named because the parent type is not present. This rule ensures that other people's code can't break your code and vice versa. Without the rule, 2 crates could implement the same trait for the same type, and Rust wouldn't know which implementation to use. So Rust needs to have... Rust cannot have 2 traits. 2 crates that implements the same trait for same type. It needs to have a unique implementation. Ooh, okay. Moving on. Default implementations. Sometimes it's useful to have default behavior for some or all of the methods in a trait, instead of requiring implementation for all methods on every type. Then, as we implement the trait on a particular type, we can keep or override each method's default behavior. So we can have a default behavior. Define here string from read more. So summarize will return a string from read more. So what's happening in here? So if we take this. Hello, Ayumi-chan, welcome. Coherence is making sure you can have the same trait implemented for the same type but in two different ways. So it can only have... How do I put it in the other way? Making sure you cannot have the same trait implemented for the same type, but in two different ways. So for one trait plus type, one trait plus type combination, there can only be one implementation. Cool. So it doesn't conflict, so the compiler knows which one to use. We're serving the compiler. Let article equals to news article, okay? We have a headline, location, author, content, and when we call the summarize, news article, it would say the headline, author, and location. But if we remove this, I think it's going to say read more. So let's do it. Let's try it. Cargo run. Do we not have news article? Summary? Go ahead, import news article. News article. Okay. And there's no summarize. Because we need to import summary. Okay. Oh good. Let's see what's gonna happen. So it prints out the summary we defined over here. But if we delete this, I think it's gonna just print out read more. New article available, read more. What error do we have? Wait, I think we do need a summary. So we cannot just delete it. Does it go like this? Is this how you use default? How do you use default? Even though we're not longer defining, wait, what? To use the default, we need to do this. Hey, I guess it right. And then use default. And yeah, it's using the default. Summary. It's the default implementations. If you just use this, you still have the summary method, but you don't do anything about it. Cool. What does this say? Default implementations can call other methods in the same trait, even if those other methods don't have a default implementation. In this way, a trait can provide a lot of useful functionality and only require implementers to specify a small part of it. There's a summarized author that doesn't have implementation. So what's gonna happen? To use this version of summary, we only need to define the summary author when we implement the trait on a type. To use this summary, we need to define summary author when we implement the trait on a type. Oh. So here is it's a method in the trait. And this one can call a unimplemented method and let those who use the trait to define how the summarized author look like. Let's try it. Let's try it. It's kind of scary. So we have a summarize that calls this summarize author, which has no implementation, and we need to implement it. Implement summary for tweet, and we need to summarize author and he returns the username. All good? And here we have a tweet. Okay. Why is this not happy? News article. Oh, why are we using news article? We need tweet. Okay. Oh, good. So our tweet implemented the summarize author. So when we call summarize on tweet, it's gonna say read more from, and summarize author is here, which is defined here, and you will say the username. So if I do cargo run, it's gonna show read more from horse ebooks. Oh yes, working. It's working. Trait as parameters. Now that you know how to define and implement traits, we can explore how to use traits to define functions that accept many different types. Are we using it with generics? We can define a notify function that calls the summarize method on its item parameter, which is one of the type that implements the summary trait. We can use the implement trait syntax. What is that? So we implement the trait summary. This is a notify function. It calls the summarize method on its item parameter. Oh, okay. And now the item becomes a generic type. It's a trait bound. Implement trait. It's a syntax sugar. Wait, what? Oh, so this actually is this. In the notify function, on the summary, we take an item and summarize it. This longer form is equivalent to example, but is more verbose. We place trait bounds with the declaration of generic type parameter after a column, and inside angle brackets. The implement trait syntax, which is here, is convenient and makes more concise code in simple cases. The trait bound syntax can express more complexity in other cases. For example, we can have two parameters that implement summary. Using the implement trait syntax looks like this. We can have two parameters that implement summary. Oh, and now it's making a bit more sense. If we wanted this function to allow item 1 and item 2 to have different types, use implement trait will be appropriate. So it will look like this. If we want to force the parameter to have the same type, we can use the trait bound. So item 1 and item 2 are the same type. So this talks about using trait as parameters. And this talks about the trait bound syntax. How do we use this? はいはい。I don't know how much I copied. Is it still wrong? Okay. It feels like I'm copying the entire world. Okay. We have a function notify. But can I use like notify plus a tweet? What does it return? A print line. Can I use it here? Notify a tweet? Like this? Notify? A reference. Okay, but is this how you use this? It is. It is. You put a tweet in. Here's a function notify. It takes an item that implements summary and summarize it. Okay, somehow it confused me. But now, like looking at this syntax trigger is making a bit more sense. So any instance of a type that implements the summary type, for any type like that, the notify will summarize it. Easy peasy. Easy peasy. Okay. And here it's saying that we can have 2 items. Item 1 summarize, item 2 summarize. So we can have a tweet 1 and tweet 2. Yeah. How am I doing? I'm figuring out 6. It's doing okay. So we have a tweet 1 and tweet 2. And then notify repassing the reference of the 2. And you summarize for both of them. Specify multiple trace bounds with the plus syntax. We can also specify more than one trait bound. Say we wanted notify to use display formatting on item as well as the summarize method. We specify the notify function. We specify the notify definition. That item must implement both display and summary. Does any of this implement display? I don't think so. And we need to implement the method. How about we do it here? Oh. Here. Okay, all good. Oh. Oh, sir. This is so messy. I just say, oh, sir. What can you do? You can use Ctrl+ to let Rust Analyzer to fill out the missing method signature for me. Wait, so if this was not, there's no default for that. And if I do this, I can do Ctrl+. No implementation font. There's no quick fixes. Ctrl+ dot. I'll come back, Ayumi. Ctrl+ dot. Implement missing members. Oh, nice! This is so cool. Welcome, Suncrest. Oh, すごい. I can just define here. And author self.content. Don't press plus. Don't press plus. Oh. Okay. I forgot to change the front side. Okay. Oh, working. Nice. Woo! Clear your trace bound with weird clauses. There are weird clauses? Using too many trait bounds has its downsides. Each generic has its own trait bounds. So functions with multiple generic type parameters can contain lots of trait bound information between the function name and parameter list. Making function signature hard to read. For this reason, Rust has alternate syntax for specifying trait bounds inside a where clause after the function signature. Oh, so instead of writing something like this, function sum function p display plus clone u colon plus debug blah 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 blah, we can use a where clause to say what kind of traits we want. Oh, so here we only worry about the type. And here we worry about what kind of a trait we want. Nice! What chapter am I on? It's chapter 10. I skipped chapter 9 because I want to learn generics today. You can bounce to a where clause for me? You can move bounce into a where clause. Really? Oh, yeah, sure. Right here. Let me write it somewhere. So if I take this, I do control parent. What just happened? What just happened? Control parent. Move to red class. Oh, it's working. It's working. Nice. This is nice. This is nice. Thank you, Frank. Returning types that implement traits. We can also use implement trait syntax in the return position to return a value of some type that implements a trait. So we're returning a trait that implements summary. Return summarizable. By using the implement summary for return type, we specify the return summarizable function returns some type that implements the summary trait without naming the concrete type. Return some type that implements the summary trait without naming the concrete type. In this case, return summarizable returns a trait, but the code calling this function doesn't know that. The ability to return a type that is only specified by the trait it implements is especially useful in the context of closures and iterators. Closures and iterators create types that only the compiler knows or the types that are very long to specify. The implement trait syntax lets you concisely specify a function that returns some type that implements the iterator trait without needing to write a very long type. However, if you can only use implement trait if you are returning a single, you can only use implement trait if you are returning a single type. What is this? You can only use implement trait if you're only returning a single type. For example, this code that returns either a news article or tweet with the return type specified as implement summary wouldn't work. So I can only return I can only return a single type if I use implement trait. Function return summarizable. This wouldn't work because it has a switch case of news article and tweet. And if we want to implement a trait, we can only have a single type. Ooh, there's so many restrictions. I don't know if y'all remember this after a few days. Hello, Mysterious K, welcome. I hope it clears out more in the later chapters. Okay, fixing the largest function with the trait bounce. Oh, we fixed it last time. because it doesn't have a compare. So we added the trait of partial order, like this. And then it worked for any type that implement partial order and copy. Using implement trait only helps you write code without caring about the type. The compiler will still pick a concrete type which the function actually returns. Oh. So it helps me to not care about the type. But do I really not care about the type? I thought we'll have to write the type here. Oh, but I don't need to care about this because I don't need to define this. Itama, welcome. Xiang, hello. Hello. Practice makes perfect. I was writing a little HTTP server yesterday. It was a bit fun with Rust. In the tweet and summary example, the only things you are guaranteed to have access to are the things in summary trait. You don't know is a tweet. I don't know it's a tweet. I just name it tweet here. It makes me more interested in this. So if I put it here, so what will happen now? It doesn't take anything. Yeah? And I don't know if this will work. Will you take? Nope. And it knows it's a summary. Can you print a trait? What's gonna happen in here? Agora. Okay, it looks like it worked. It doesn't know it's a tweet. How do I make this show up? Debug? Debug? Oh. So if I use this, even if I use debug though, it wouldn't be able to print it. But we know it returns a tweet. Or do we know it returns a tweet? It doesn't know. It doesn't know it returns a tweet. It only says that it's an implement of the summary. It cannot be formatted. It cannot be printed. Okay. Moving on. We have done of that. We have done those. Use trademarks to conditionally implement method. By using a trademark with an implement block that uses generic type parameters, we can implement methods conditionally for types that implement specific traits. Wait, what? How do I do implement summary plus debug? Is it doable? I can do this. What? Let's need to derive debug. Where do I? Ale? Can you guys still hear me? I cannot hear myself for some reason. I'm back. Rob, thank you for subscribing. Oh, what? I can press F12 to jump? I was trying to figure out how to click into it. Okay, so... derive it. And... oh, okay. So like this? Okay, it worked. So we derived from debug how to format the tweet. And then implement the debug. Oh, thank you for helping. Now we can see the actual contents of the tweet. Nice. Okay, moving on. Using trade bonds to conditionally implement methods. By using a trade bond with an implement block that uses generic type parameter, we can implement method conditionally for types that implement specific traits. Okay. The peer type always implements new function to return a new instance. What do we have here? We have a peer. And there's a method that returns the peer. And this method only works if the type can be displayed and can be compared. It shows the largest number. Okay. Compare display. We can also conditionally implement a trait for any type that implements another trait. Implementations of a trait on any type that satisfies the trait bounds are called blanket implementations and are extensively used in Rust standard library. The standard library implements toString trait on any type that implements display trait. The implement block in the standard library looks like this. Oh, so when there is a display trait, there's a toString that has been implemented. So this is why the conditionings display here. So if we implement a trait for any type that implements display, if there's any type that implements display, we can give it another trait by doing this. Conditional implement comes from Haskell type class. Ooh. Ooh. Time to relearn Haskell. Thank you, Celia. Cecilia, thank you. I'm happy that we gave you some motivation. Coding is fun, especially with everybody here. Thank you for all the nice discussions. Fun fact, you can even jump to the definition of standard library stuff with F12. Which part is standard library? I think debug is standard library, right? Can I jump to it? Can I jump to it? I can! Yay! I'm in standard library. This is how they define the trait debug. There's 685 implementations. Everybody uses debug. I can read the source code. It's amazing. F12. Nice net. Every day I learn something new from the chat. Thank you. Thank you. Okay, what do we have here? Because the standard library has this blanket implementation. Blanket? Yes, we can call toString method defined by toString trait on any type that implements the display. For example, we can turn integers to their string like this. What? We time out. Blanket implementation. Oh, there's no output, of course. It's just going to be a string of 3. Blanket implementation appear in the documentation for the trait in the implementer section. Trait and trait bounds let us write code that use generic type parameters to reduce duplication, but also specify to compiler that we want generic type to have particular behavior. The compiler can then use the trait bound information to check that all the concrete types used with our code provide the correct behavior. In dynamically typed languages, we will get an error at runtime if we call the method on time, which didn't define the method. But Rust moves this error to compile time, so we are forced to fix the problem before the code is even able to run. Additionally, we don't have to write code that checks for behavior at runtime, because we already check at a compile time. Doing so improves performance without having to give up the flexibility of generics. Another kind of generic that we already been using is called lifetimes. Rather than ensuring that a type has the behavior we want, lifetimes ensure that the references are valid as long as we need them to be. References are valid as long as we need them to be. Okay, we're messing with the borrowing now, are we? It's lifetimes. Let's go. It's a long chapter. Can we finish this? Let's try finish this. Let's go, lifetimes. How do you do it? Argo new project. Oh, I bet. Project. Okay. Open folder. Project. Okay. Lifetimes are the one of the coolest but hardest to learn feature of Rust. Oh my god. Oh my god. I'm gonna get so nervous. That's why I started a new project. I was like, oh, time to do it. We're doing lifetimes. Let's go. Validating references with lifetimes. One detail we didn't discuss in reference and borrowing is that every reference in Rust has a lifetime, which is the scope for which the reference is valid. Most of the time, lifetimes are implicit and inferred. Just like most of the time, types are inferred. We must annotate the types when multiple types are possible. In a similar way, we must annotate lifetimes when the lifetimes of reference could be related in a few different ways. Oh, what? There can be few different ways? The lifetime can behave Rust requires us to annotate the relationship using generic lifetime parameters to ensure the actual references used at runtime will definitely be valid. Annotating lifetimes is not even a concept most other programming languages have, so this is going to be feel unfamiliar. Although we won't cover lifetimes in their entirety in this chapter, we'll discuss common ways you might encounter lifetime syntax so you can get introduced to the concept. At least lifetimes have gotten easier to work since I used Rust. Oh really? It's evolving. You're welcome, Cyan. I'm happy that I made you happy with my message. Thank you. Thank you, Cecilia. Hope you have fun coding. Okay, let's look at this. Oh. The main aim of lifetimes is to prevent dangling references, which cause a program to reference data other than the data that's intended to reference. Consider this program which has an outer scope and inner scope. We have let r, let x equals to 5, r equals to a reference of 5, but it wouldn't work. It declares the variable without giving them an initial value, so the variable name exists in the outer scope. The outer scope declares a variable r with no initial value, and the inner scope declares a variable named x with initial value of 5. Inside the inner scope, we attempt to set the value of r as a reference to x. Then the inner scope ends, and then we attempt to print the value of r. But the code won't compile because r is referring to x, which has gone out of scope. So the variable x doesn't live enough. The reason is that x will be out of scope when the inner scope ends on line 7. But r is still valid for outer scope because the scope is larger. We say that it lives longer. If Rust allowed this code to work, r will be referencing the memory that was deallocated when x went out of scope, and anything we try to do with r won't work correctly. So how does Rust determine that this code is valid? It uses a borrow checker. The borrow checker. Lifetime makes people have a good lifetime. Really? Really? Been chilling? Been silly? Nice. なるほど。なるほどね。So what is a borrow checker? Borrow checker compiles scopes to determine whether all borrows are valid. The lifetime of x is inside this, and lifetime of r is inside this. And here, I feel like the lifetime of x. Where is the lifetime of x? Oh, lifetime of x is this whole thing. And lifetime of r is here. The subject of the reference doesn't live as long as the reference. Which is here. the subject of the reference doesn't leave as long as the reference. So this gets rejected. And here it got fixed. X has a lifetime B. And R has a lifetime of A. Generic lifetimes in functions. What is generic lifetimes? Oh, I'm muted. I'm muted. I'm muted. I got too excited. I was muted. Dang. Thank you, chat. 欢迎刘小艺。I was drinking some water and I got muted. Okay, where did I start to be muted? Am I still muted? Akil mute is still muted. Hello, Maria-san. Good morning, welcome. Generic functions, what? We are at generic lifetimes. Rasta 好耶，欢迎。Okay, where are we? We talk about we have two string slices, and then we try to put it into a function. And return a string slice, but it wouldn't let us do that because we need a lifetime parameter. I was wondering why you're so quiet. Is it because I drink or is it because I cough? I sneeze. I mute myself and forget to turn it back. I'm such a baka. Okay. So, what are we saying here? What are we seeing? The help text reveals that the return type is a generic lifetime parameter because Rust cannot tell whether the reference being returned refers to X or Y. When defining this function, we don't know the concrete values that will be passed into the functions. So we don't know whether if case or else case will execute. We also don't know the concrete lifetimes of the reference that will be passed on. So we can't look at the scopes. The borrow checker can't determine this either because it doesn't know the lifetime of X and Y relate to the lifetime of the return type. To fix this error, will add a generic lifetime parameters that defines the relationship between the reference, so the borrow checker can perform analysis. I need a recording lamp to make the muted visible. I really might. And I think my internet is going down. Dang it. Is it a signature that I should start to continue this next time? I think my internet is kind of horrible now. Let me try to ping Google. Are we good? 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 I think like my neighbors are waking up and the internet starts to have traffics. It's okay now? Okay, do you want to try to finish lifetime? Okay, let's go. Let's go. Let's get this done. So basically we're saying we don't know if the return type or the return value is a borrowed value, but we don't know if we borrowed this from X or borrowed this from Y. And they have different lifetimes. So Rust got confused. Which code would execute? It can't find out the lifetime because it's dependent on the input. So he refused to compile for us. Finish learning about lifetime is more ambitious code than what you can reach in a day. It's so hard. Isn't that hard? Let's unpack it. Let's see how hard it is. Lifetime annotation syntax. What is this? What is this? Lifetime annotation don't change how long any of the reference live. Just as functions can accept any type when signature specifies a generic parameter, function can accept reference with any lifetime by specifying a generic lifetime parameter. Lifetime annotations describe the relationship of lifetimes of multiple references to each other without affecting the lifetimes. Lifetime annotation have a slightly unusual syntax. The names of a lifetime parameter must start with a apostrophe, and are usually all lowercase and very short. Like generic types. Okay, so you start with apostrophe and all lowercase and very short. Most people use the name a. Replace lifetime parameter annotations after the reference. Replace the lifetime parameters after the reference using a space to separate the annotation from the reference type. I remember I spent a whole year to understand all Rust invented concepts. Oh my god. What have I gotten myself into? Anyways. Here are some examples. A reference to i32 without a lifetime parameter. A reference to an i32 that has a lifetime parameter. And a mutable reference to i32 that also has a lifetime. Okay? One lifetime annotation by itself doesn't have much meaning because the annotations are meant to tell us how generic lifetime parameters of multiple references relate to each other. Huh? For example, let's say we have a function with a parameter first, that is a reference to an i32 with a lifetime. The function also has another parameter named second, that is another reference to an i32 that also has a lifetime. The lifetime annotation indicates that a reference first and second must both live as long as that generic lifetime. Oh, what? So we have a function with two parameters first and second, and if they have the same lifetime, then they'll live as long as that generic lifetime. Does it mean they live the same amount of time? I read the lifetimes as tika. Tika? So cute. Tika. I'll say it. Tika. Tika? I just say I'm trying to make trust my own language, so I just say it. Lifetime annotations in function signatures. Now let's examine lifetime annotation in the context of longest function. So many. As with generic type parameters, we need to declare generic lifetime parameters inside angle brackets. In angles between the function name and parameter list. The constraint we want to express in this signature is that the lifetimes of both the parameters and the lifetimes of the returned reference are related such that the returned reference will be valid as long as both the parameters are. Okay, so by using all this we're saying that the lifetimes of x and y and lifetime of the returned stuff will be the same. Okay. The code should compile and produce the result we want with the main function. What does it do? So we have a main function, abcdxyz. And then we take longest, we put string slices in it. In the longest we have our generic generic lifetime. And we give it to x, to y, to the return value, and boom, it just works. It just works. No, where did my terminal go? Oh. My internet is bad. Okay, I guess the internet gets unstable again. But we got introduced to lifetime. Let's continue next time to learn more about the lifetime. I feel like this worth another stream to talk about lifetimes and truly understanding. I'll do some starting ahead. I'll put lives as long as or shorter than the input is a rule of thumb. Ah, you can also guess shorter. As long as it's within the life of the input, you can output the life of the output. Okay, my internet is struggling a bit. I don't think we learned a lot today. We did learn a lot today. We learned about generics. Which is how option and result are implemented. We learned about shared behaviors, default traits, cool stuff. And then we learn a little bit about lifetimes, and we'll continue lifetimes the next stream. Oh, internet, at least let me end the stream properly. Oh, my internet. It is so slow. Can anybody hear me? Well, it just dies. I still want to say goodbye. Let me say goodbye. Everybody's saying in the chat. Let's say Ah. Can anybody hear me? Is my chat currently panicking? For anyone who wants to learn even more in-depth stuff about lifetimes, the ownership chapter of the Rastonomicon is a useful resource. Oh, I want to learn about it. I'll read about it. Okay, I am going to end the stream now. Thank you guys for watching, and see you guys next time. Bye bye. Prima. Thank you, super sexy boing boing big oppa neko mini one-chan. Thank you, Frank, so much for helping me. We're learning so much from you. Arigato. Thank you, Maria-san. Thank you, Cecilia. Thank you, Yufan. Thank you, Ron Plasma. Thank you, Ayumi. Thank you, Hafnia. Thank you, John DeHay. Thank you, Mitama. Thank you, Ben. Meow. Oh my god, the stream is totally dead. It's totally dead. It's totally dead. No. We're ending the stream. Thank you for coming. Thank you for coming. I can't even log into Google. Uh-oh. You're offline, check your connection. Uh-oh.